So for this video, we're going to be talking about electron arrangements within atoms. So we're going to think about electron shells, subshells, and orbitals, and think about how they are used to describe our electron arrangement within an atom. So we're going to look at some pictures here, and these pictures are of orbitals. So if we think back to what we just talked about, we've got shells, subshells, and orbitals. So what we're seeing here in these pictures are the orbitals, all right? So we have s orbitals, p orbitals, d orbitals, and f orbitals. The p orbital is also considered a subshell, so the p subshell. The p subshell has 3 p orbitals. So subshell and orbital can be a little bit confusing sometimes because p subshell, p orbitals, the naming's a little close, right? So there's an s subshell, and inside that s subshell is one s orbital. P subshell has 3 p orbitals. The d subshell has 5 d orbitals, and then your f subshell has 7 f orbitals. So that's how we can relate subshells to orbitals. Shells are the even bigger range yet. If we think about electron configuration, which we will get to here in a minute, but I'm going to throw one up here real quick because you have seen these before. So the superscript number is the number of electrons that are in that subshell. Right, here's our subshell. There's 2 electrons in that subshell. The number 1 in front is the number of the shell. If I look at the next option, I have shell number 2 that has both s and p subshells in it. The s subshell has 2 electrons. The p subshell has 6. All right. That p subshell, there are 3 orbitals, and each orbital has 2 electrons. So if we can kind of see the hierarchy here, going from shell being the big picture, subshells next layer down, and then orbitals, the kind of the most narrow range that's actually holding the 2 electrons each. So let's look at some examples here and decide if these statements are true or false. So A says an orbital has a definite size and shape, and the size and shape is related to the energy of the electrons it could contain. So we haven't talked much about energy, right? We just saw the orbital pictures, and they do have a definitive size and shape, and that is to do with the energy of the electrons. So this is a true statement. B says all of the orbitals in a subshell have the same energy. This is going to be false. And if we think back to what we just saw on the last slide, thinking about it with the electron configuration, for example, we have the 2s subshell. There's the s orbital in there. There's only one orbital. We have the 2p subshell, and all of 3 of those p orbitals have the same energy. Now the p orbitals don't have the same energy as the s orbital, but the way I read this question is each subshell, so 2p is the subshell, all of the orbitals in that subshell have the same energy. C says all subshells accommodate the same number of electrons. This is going to be false. So if we go back to this previous example, the 2s subshell can hold 2 electrons. The 2p subshell can hold 6 total. So that's going to be a false statement. A 2p subshell and a 3p subshell contain the same number of orbitals. This is true, because there will always be 3 p orbitals in a p subshell, no matter which overall shell they are found in.